All right, guys. So today I'm going to go over the review with you, which means everyone should get a free replacement grade. That's what this is going to count as. So I'm going to go in and I'm going to replace your lowest grade as long as you complete this review and turn it in to me before your final date. If you're not sure what the final date is, make sure you've gone in and looked at the scheduling because it's different for every period. Okay. If you guys have any questions after this review, make sure you're messaging me. The semester exam, it's going to be very similar to this review. You're allowed to use the review on your semester exam. It's 10% of your grade, so make sure you're getting it completed. Guys, it's very, very difficult to pass a semester without doing the semester exam. That is giving away 10 points. So literally, if you have an 80 average for the first and second 9 weeks and you choose not to do the semester exam, that's going to drop your grade 10 points already. So you're in bad shape if you don't take the semester exam. Again, everyone should do well because it's very similar to this review. I'm going over the review, and you should have completed the review by the time that you take your final. Okay? All right, so let me share the screen. All right. I will also provide the Desmos link so that you guys can use your graphing calculator. All right, so question number 1 says, which of these graphs represents the solution to this system of linear equations? Okay, so first of all, since it's giving me my answer choices as graphs, it's a good idea to get these so that I can graph these equations. Remember, in order to graph equations, you need to be able to put them into slope-intercept form, which is y equals mx plus b. So we need to get both of these equations such that their y is isolated. So let's start off with our first equation, 4x minus 2y equals 8. I'm being kind of risky using pen today. I should be using a pencil, but hopefully I don't make any mistakes. All right, if we want to get y by itself, the first thing we're going to do is we're going to subtract 4x from the left side. That way, the 4x and the negative 4x will cancel out. But remember, whenever you do any sort of math on one side of your equation, you have to do it on the other side of your equation as well. So I am not able to put 8 and minus 4x together since one of them has a variable and one of them doesn't. So we're going to rewrite our equation. I drop down the negative 2y, and we get negative 2y equals negative 4x plus 8. Now, our y is almost isolated, except the negative 2 is messing things up. What is the negative 2 doing to our y? The negative 2 is multiplying. In order to undo multiplication, we need to divide. So we're going to divide by negative 2. That way, they cancel each other out and leave me with just y equals. But remember, whenever I do any sort of math on one side of my equation, we must do it on the other side as well. So we need to divide every term by negative 2. So simplifying, negative 4 divided by negative 2 is 2 with an x. Positive 8 divided by negative 2 is negative 4. So our equation is y equals 2x minus 4. Now, guys, we could put this into our Desmos, but by now we should be good at graphing these equations. So now that I have it in y equals mx plus b, it should be easy to identify our m. Remember, our slope is the number that's in front of the x. So in this case, our slope is 2, which I'm going to make into a fraction so that we can do rise over run. And then my b, my y-intercept, is the number after the x, so my y-intercept is negative 4. So we know that we're going to have a graph that has a y-intercept at negative 4 and a slope of 2 over 1, or rise 2 and run 1. Let's see. Answer choice A, y-intercept at negative 4 and a slope of up 2 over 1, up 2 over 1, up 2 over 1. Hey, that is one of my lines. That is the line y equals 2x minus 4. Answer choice A is looking pretty good so far. What about answer choice B? So answer choice B, if I try to graph my line with a y-intercept at negative 4 and a slope of up 2 over 1, that does not fit any of those lines. So answer choice B is automatically out. What about answer choice C? Well, let's graph our equation. We have a y-intercept at -4. Wait a second. Neither of those lines go through -4. So answer choice C is out. What about answer choice D? Answer choice D, a y-intercept at -4 and a slope of up 2/1. Up 2/1. Okay, good. So answer choice A and D are the only two answers that are still viable. They're the only two that have that equation graphed. Now we can focus on our second equation, x minus y equals 1. Again, we can't graph this right now because it's not in y equals mx plus b. So we got to make it. Just like we did before with our other equation, we're going to make this into y equals mx plus b. So we're going to subtract x from the left side. That way they cancel out. If I subtract x from the left side, I need to subtract x from the right side. And we're left with negative y equals negative x plus 1. Now, a lot of my students, they typically say, okay, we're done. Y is all by itself. But that's not the case. We have a negative sign in front of our y. Now, if you're not in my class, if you're not in Coach Easton's class, if you're one of the other algebra kids who is just watching this video, I'm going to show you guys a cheat. Maybe your teacher has shown it to you guys. If not, here's the first time, okay? We want this to be a positive y. So what we can do is we can just make it a positive y. We can change the sign of that term. But if you do that, you need to change the sign of every term. So here's what I mean. Instead of it being negative y, we're going to make it positive y. But if I do that, I have to change the sign of these two terms as well. So instead of negative x, now it's positive x. And then instead of positive 1, it's now negative 1. So now this equation is in y equals mx plus b. Okay, so that's just a little cheat. Technically, all I'm doing there is dividing by -1. All right, so now that it's in y equals mx plus b, my slope is the number that's in front of the x. I know you can't see a number. That means there's an understood 1. So our slope is 1/1, and our y-intercept is -1. All right, so let's look at our two options here. We said answer choice A and answer choice C. So answer choice A, does one of our lines go through the y-intercept at -1? Uh-oh, it doesn't. The other line does not go through -1. So A is out. Let's try this one. -1 is my y-intercept, and then we have a slope of 1/1. Rise 1, run 1. Rise 1, run 1. Yep. So really, all we did here, guys, is we converted these into y equals mx plus b, and then we matched the graph with those equations. That's it. All right, moving on. Question 2. This is a special question. So it says that we want to find, so we have two different equations. This is the table for equation A, and this is the table for equation B. And we want to know where the solution is to the system. So I'm actually going to take you back to question number 1. Remember, the solution to a system of equations is where your two equations intersect. It's where your two lines share a point. So wait a second. If the solution is where our lines intersect, and they intersect at the shared point, then we just need to find what point both of our equations go through. So let's see. Can you guys see if there's a point that both of these tables have? Well, if I look at them, this equation, this table, has the point 2, 0. And this equation, this table, has the point 2, 0. Both of these lines go through the point 2, 0, which means that's where they intersect. And the intersection is where our solution is for a system of equations. So H is the only viable answer in this case. Okay? All right, moving on. Question number 3. Now, guys, I got to be honest. I think this is the most difficult question on here. Okay? So word problems can always be a little bit tedious, and the sign on this one is difficult. So let's watch. You are buying a hamburger for yourself and fries for your friends. You have a limited budget of $Y. So we don't know what our budget is. We don't know what the number is. So we're going to call it Y. Y is our budget. Now, if you're not sure what a budget is a maximum amount that you can spend. So we're not allowed to spend more than Y. Okay, we can't spend more than Y. All right, it says a hamburger costs $3.50 and fries cost $1.75 each. And we want to write a linear equation to determine how many fries we're going to purchase. So what we're trying to find out is how many fries we can sell. So X is going to be our fries. We're trying to buy more than just one fries. Okay, so how much are we going to spend? Well, we're going to spend $3.50 on a burger, and we're going to spend $1.75 per fry. So remember, the word per means multiply. So we're going to take $3.50. We're going to spend $3.50 on a burger. And then for each fry that we purchase, we need to multiply by 1.75. All right. So automatically, looking at your answer choices, we should be able to get rid of D, and we should be able to get rid of A. The reason we can get rid of D and A, look at where X is. X is attached to the $3.50. We're not buying multiple burgers. We're buying multiple fries. We're not buying multiple burgers. We're buying multiple fries. So now we get it down to B and C. And this is the part that I think is a little bit difficult. All right. So this is the amount of money that we're going to spend, and we cannot spend more than our budget. This right here can be less than our budget or equal to our budget. So the right side can be equal to our budget, or it can be, this right side can be less. So I'm going to have the mouth open towards our budget. So the answer should be B. The answer should be B. All right, I'm going to pause for 1 second. All right, sorry guys. Let me continue on. Yep. All right, so the answer there should be B. I just wrote it backwards. It's okay, whichever order we want to write it. It's the same exact answer. Just make sure we're using the correct inequality here. All right, question number 4. Which inequality is graphed below? So actually, there's a couple ways that we could go about this, all right? I want to see how good you guys are at kind of working backwards. So instead of trying to convert all of these initially, let's see if we can come up with what the equation should be just from the graph, okay? So we are using a dashed line. So that means it's not equal to. And we're shading below. Whenever you shade below, that means you're going to use the less than symbol. So Y is less than. All right, next, if we were to make this into mx plus b, let's figure out what our slope is. So what is the slope? Sorry, I'm going to zoom in extra so I can take a look at it. All right, what would our slope be? So it looks like we're just going up 1 over 1, up 1 over 1, up 1 over 1. So our slope is 1. We're going to put our x there. And then what is our y-intercept? Where are we crossing the y-axis? We're crossing at a height of 4. So this right here is going to be what our equation should be. All right. Now, unfortunately, if you look at all of your answer choices, they're not in y equals mx plus b. They're not in slope-intercept form. They're all in standard form. So we're going to have to convert these, okay? It should actually be really, really easy. So first of all, let's take a look at this one. If I want to get y by itself, we just need to add x. And if we add x to one side, we got to add x to the other side. So y is less than x plus 4. Hey, what do you know? F is already our answer. Boom, they match up. That's all I needed to do. It's that easy. None of these other equations, or sorry, none of these other inequalities would give us the line that we just found for our inequality. All right, that's it. Okay, so a system is shown below. A system is shown below. Which of the following is the solution to our systems? So guys, we've learned a whole bunch of ways. We've learned substitution. We've learned graphing. Those of you guys that are face-to-face kids, Mr. Arnett took you guys that one day and showed you guys how to do it if you have a TI Inspire. But what I'm going to do is I'm going to focus on the graphing. I think the graphing is pretty easy, okay? So we're going to actually use our Desmos, but in order to graph these equations, we need to get them into y equals mx plus b first. Okay, so 3x plus y equals 6. If I want to get this into y equals mx plus b, well, then we're going to have to subtract 3x from the left, which means I need to subtract 3x from the right. I cannot put these two terms together, so that gives me negative 3x plus 6. And there you go. So we're actually not going to graph this by hand. We're going to let our calculator do the graphing for us. Okay, so we'll hold on to that. Let's go ahead and convert this other equation as well while we're here, and then we'll go back to the Desmos and plug them both in. Okay, all right, first thing I need to do is subtract x. If I subtract x from the left, I need to subtract x from the right. So we get negative y equals negative x minus 2. Now, guys, I'm going to use that little trick that I used on the front page. I don't want negative y, I want positive y. So let's change the sign. But if I change the sign of one of my terms, I have to change the sign of all of my terms. So instead of it being negative x, it's now going to be positive x. Instead of it being negative 2, it's positive 2. And now we just need to graph this equation, and then we need to find where they intersect at. Easy enough. All right, so I'm going to share with you guys the Desmos, which is going to do all of the graphing for us. So the first equation was y equals negative 3x plus 6. There you go. We have a y-intercept at 6. We're going down 3 over 1, down 3 over 1. All right, and then our other equation was y equals x plus 2. All right, and now we're trying to find where they intersect at. And if I just look right here, it even shows me the point. So they cross at the point 1, 3, which means that is the solution to this system. And that is answer choice D. So go ahead and circle answer choice D on our paper. Easy enough. All right, moving on. All right, a system of two linear equations is shown in the graph. Which system of equations can be used to represent the graph? So again, this is very similar to what we did in question number 1. If you guys look back at question number 1, it's kind of the opposite of question number 1. Question number 1 gave you two equations and you had to find the graphs that matched it. And now we're doing the opposite. Now I've given you a graph and you have to find the equations that match it. Okay? Unfortunately, all of these graphs are in standard form. Yuck. Again, you guys are going to get tired of this, but you have to make them into y equals mx plus b in order to graph them. Okay? So let's start with option F. Okay? So the first equation is x plus y equals negative 5. If I want to get this into y equals mx plus b, we're going to subtract x from the left side. If I do it on the left, I got to do it on the right. So y equals negative x minus 5. All right, what is the slope here? Remember, m is the number that's in front of x. Sorry, I need to move this over. M is the number that's in front of x. So what's the number that's in front of x there? It is technically negative 1, which we're going to write as negative 1 over 1. And then we have a y-intercept of negative 5. So let's graph this equation. We have a y-intercept at negative 5. Wait a second. Oh, okay. Negative 5. 1, 2, 3, 4, 5. And then we have a slope of down 1 over 1. Yep. Okay. So that matches our first equation. So that first equation matches that line right there. So x plus y equals negative 5. That's looking pretty dang good. Let's see if this second equation matches the second line that we have graphed. So 8x minus 4y equals 8. All right, subtract 8x from the left. If I subtract 8x from the left, I got to do take away 8x from the right. Now I'm not allowed to put these two together since this has a variable and this doesn't. So we get negative 4y equals negative 8x plus 8. It's positive 8 since this 8 was positive. Now the negative 4 is multiplying y. So to undo multiplication, we need to divide by negative 4. But if I divide the left by -4, I need to divide everything on the right by -4. So let's do a little bit of simplifying. -8 divided by -4 is 2x. And then 8 divided by -4 is -2. Now we have this in y equals mx plus b. And if I look at it, we have a slope of 2, which I can write as 2 over 1. And I have a y-intercept of -2. All right, does that match my other graph? A y-intercept at -2, and then a slope of up 2 over 1. So right here, yep, that works out. All right, so I want to show you guys another way. Maybe this is going to be a quicker way. Another way that we could have answered this question. First of all, can you guys find the point that they intersect at? Where is this point that our two lines intersect at? So that is -1 as my x value, and then down 1, 2, 3, 4. -1, -4 is where they cross. That means x is -1 and y is -4. So here's another way that you could have done this. We could have plugged in -1 for x and -4 for y and seen if it worked for both of our equations. F is the only answer that has two equations that -1 and -4 would satisfy. For instance, here's what I mean. What if we tried to plug in -1 and -4 into answer choice H? So -1 is x and -4 is y. What does that equation now become? -1 plus -4 equals 5. Is that true? -1 plus -4 is -5. Is -5 the same thing as 5? No. So it does not work for option H. So this is another way that you guys could have gone about doing this problem. Okay? All right. Let's move on. Question number 7. Which of the following is not? Okay, so let me highlight that. That's a key word. So remember, whenever you're graphing inequalities, we know that our solution is where the double shaded area is. So this really dark region right here is our double shaded area. Any point in this area is a solution. Any point that falls in that really dark area is considered a solution. For instance, answer choice A says the point 1, 1. That's right there. Guess what? That is in our dark shaded area, which means 1, 1 is a solution. But we are looking for which point is not a solution. So answer choice A is out. All right. I'm going to go through this in an odd order just because I already know the answer. Look at D. 0, 0. That is in our double shaded area. So that is a solution, which means we're looking for some other point. What about 4, -2? So 1, 2, 3, 4, and down 2. That point is also in our darker shaded area. So B is out. Okay, so that only leaves C. So let's verify. -4 and 4. -4, 4 is in our lighted shaded area, which means it's in one of the inequalities. It'll satisfy one of our inequalities, but it does not satisfy both of our inequalities. It has to be in the double shaded area to be a solution for a system of inequalities. So -4, 4 is not a solution, and that's what we were looking for. I like that question. I like that question. All right, a system of equations is shown below. Which ordered pair represents the solution to the system of equations? So again, guys, we have a whole bunch of ways that we can go about this. We can either use substitution, we can use graphing, or we can guess and check, which is what I showed you guys up here on question number 6. We could find our solution and plug it into the equations and see if it works. So I'm going to actually do that, because if we wanted to do graphing, we would have to get these into y equals mx plus b. And that's going to take a little bit of work. So here's what we're going to do. Let's try answer choice F. Answer choice F says 1, 3, which means the x value is 1 and the y value is 3. If this is going to be my answer, 1, 3 has to work for both of these equations. So we're going to plug in 1 for x, and we're going to plug in 3 for y. So I kept this equation exactly the same, equation number 1, and I'm plugging in 1 for x, and I'm plugging in 3 for y. Let's see if it works. Well, 3 times 1 is 3, and 2 times 3 is 6. Is 3 plus 6 equal to 5? No. So answer choice A is already out. It did not work for equation number 1. All right, let's try answer choice G now. So we're going to plug in -3 for x, and we're going to plug in 4 for y. So again, I'm going to do this using my first equation. 3 times x, which we called -3, plus 2 times y, which we're going to plug in 4, is equal to 5. Let's see if this works. 3 times -3 is -9. And 2 times 4 is +8. Is -9 plus 8 equal to 5? No, that's not true. That doesn't work. So the point -3, 4 does not work for our first equation. It's out. All right, same thing. Let's try this for h. X and y, there it is. So 3 times x, which is -4, plus 2 times y, which is 2, equals 5. Let's see if this works out. So 3 times -4 is -12, plus 2 times 2 is 4. Is -12 plus 4 equal to 5? No, wait a second. None of those worked out. So the answer to this has to be no solution. Now, guys, what if we wanted to do this with graphing? Okay. I want to show you guys something here. So if we wanted to solve this by graphing, instead of just guess and check like I did right there, we would have to get both of these equations into y equals mx plus b. I'm going to do that really quick, okay? So y equals -3/2x plus 5/2. There's your first equation, now in slope-intercept form. And my second equation, y equals -3/2x plus 1/2. Let's graph these two equations. So I did the hard work there. I went ahead and put them into y equals mx plus b. I'm going to graph these two equations on Desmos, and let's see what shows up, okay? So we're going to do a new share. All right, let me get rid of these old equations that we had. All right, so one of our equations was -3/2x plus 5/2. There it is, beautiful graph. Our other equation was y equals -3/2x plus 1/2. Look at these two equations. Now that they're graphed, are they ever going to intersect? I can't find their intersection. What do we call these lines? These are called parallel lines. In parallel lines, they never intersect. And if they never intersect, then there is no solution to this system. And that's exactly what we just proved. We did it a different way, but that's exactly what we just found our answer to be when we did it by guessing and checking, okay? So there is a whole bunch of ways that you can do these problems. I like graphing. I would always get them into y equals mx plus b. But on multiple choice tests, you guys can always use your resources. Plug in those numbers and see if they work. And if they don't, they got to be the wrong answer. Okay? All right, moving on. Question number 9. Question number 9. All right, we have an inequality here, and we have it graphed, and we need to see which of these equations works with it. Again, we have to always get them into slope-intercept form. I know we're dealing with inequalities, not equations, but we got to get them so that the y is isolated. That way we can graph them. So let's start with answer choice A. 5x minus 3y is less than or equal to 12. I need to subtract 5x from the left, which means I need to subtract 5x from the right. What are we left with? Negative 3y is less than or equal to negative 5x plus 12. Last but not least, the negative 3 is multiplying, and in order to undo multiplication, we need to divide. So we need to divide by negative 3. All right, pause. Before you go any further, I need y'all to, at the top of your page, disclaimer, I'm going to put a star here. If you ever multiply or divide by a negative number, if you ever multiply or divide by a negative number, you need to flip the inequality. All right, so right here, we just divided by negative 3, so we need to flip the direction of the inequality. So y is greater than or equal to, and then now we can start to simplify our fractions. Negative 5 divided by negative 3 is 5 over 3x. 12 divided by negative 3 is negative 4. And guys, I can already tell this answer is wrong. And here's why. It says y is greater. And if we want to shade greater, that means we need to shade above the line. This is shaded below. So answer choice A is out. Sorry. Okay. Got to do it for answer choice B now. So answer choice B. Subtract 5x from the left. Subtract 5x from the right. So we get negative 3y is greater than or equal to negative 5x plus 12. Then we divide by negative 3. If I divide the left by negative 3, I need to divide the right by negative 3. Now pause. We just divided by a negative number, which means we need to flip the inequality. So y, flip that inequality. Y is less than or equal to 5/3 x minus 4. All right, let's graph this. We have a y-intercept at negative 4. All right, that's looking good so far. Our slope is 5 over 3, meaning we rise 5 and we run 3. Up, 1, 2, 3, 4, 5. Run, 1, 2, 3. Hey, that's looking pretty good. Last but not least, I have the equal to sign, so it needs to be a solid line. That matches up. And now, I really mean last but not least, now, y is less than. So we shade below. So answer choice B is that inequality right there. So guys, make sure you are still using slope-intercept form, and make sure you remember, whenever you're doing that, if you divide by a negative number, you need to flip the inequality, okay? All right. Question number 10. Ooh, word problems, everybody's favorite. All right. I always like to read through my word problems first and then go back and identify the key information. It just helps me out once I know what we're looking for, okay? So Amber has a jar of 145 dimes and quarters. The total value of the coins is $33.50, or sorry, $35.50. Which system of equations below would be the best to find the number of dimes and quarters? So we're trying to figure out the amount of dimes and quarters. Normally, I would tell you guys to use X and Y. So maybe we would do X as dimes and Y as quarters. But if you notice, look at our answer choices here. Look at your answer choices here. They don't use X and Y. They use D and Q. Well, D is for dimes and Q is for quarters. Okay. So we know that in total, we have 145 coins, and they have a value of $35.50. So I don't know how many dimes I have. I don't know how many quarters I have. But if I combine them, how many total, so I said the word combine, which means add. How many in total do I have? How many coins in total do we have? We have 145 coins in total. All right, looking at our answer choices, it looks like it's down to F and H. Now, I'm kind of curious, where are they getting 0.25 from and 0.10 from? Well, that's the value of a dime and the value of a quarter. We know dimes are worth 10 cents. So we have 10 cents per dime, 10 cents times D. We know quarters are worth 25 cents. So 0.25 times Q. And if we add up our money, money plus money equals more money. So $ plus $ equals $. So 35.50. All right. Now look how goofy answer choice F is. F is saying it's 25 cents for every dime and only 10 cents for every quarter. So that has those flip-flop. That's wrong. So answer choice H has to be the system. Remember, units plus units equals units. How many dimes, how many quarters equals how many coins. Money plus money equals money. All right, the units go together there on those word problems. All right, which of the following represents a system with no solution? All right, we just talked about no solution. No solution means they do not cross, they do not intersect. So automatically A and D are out because we can see that they are going to intersect. This would be the solution for A. This would be the solution for D. So now B and C are the only ones that don't cross. And actually, if you look at it, B, they will eventually cross. Those two lines will eventually cross. They're just crossing outside of our visual plane. We can't see where they're going to cross, but we can tell that they are going to cross since they do not have the same slope. So answer choice B, it does have a solution. It does have an intersection. C, these lines are parallel. They will never cross. If they never cross, there's no intersection. If there's no intersection, no solution. So answer choice C. That's probably the easiest one on this whole page. As long as you know that your solution is where your lines cross. If your lines don't cross, there is no solution. All right, just a couple more. Sorry, having trouble picking this up. Just a couple more. Question number 12. All right, so this is we're gonna have to come up with these two inequalities because we have some shading. All right, I'm gonna show you guys a couple of tricks here. One of the things I see is that some of my answers have no equal to, like answer J has no equal to bars. Answer choice G has 2 equal to bars. Answer choice F and H, they both have just 1 equal to bar. And here's what we know. Whenever you're graphing, we know that if there's no equal to bar, you have to use a dashed line. If there is an equal to bar, we use a solid line to graph them. So let's look at our problem here. One of our lines is solid and one of them is dashed. That means that we have to have one of each. One of our inequalities will have an equal to bar and one of our inequalities will not have an equal to bar. So answer choice J, that would represent 2 dashed lines, but we don't have 2 dashed lines. Answer choice G, that would be 2 solid lines, and we don't have 2 solid lines. We have 1 line that's solid, and we have 1 line that is dashed. So just by doing that, I'm not going to do any math yet. Just by looking at what type of lines our inequalities use, we already have it down to 2 answer choices. Okay? All right, now we're going to have to do a little bit of work to get them into y equals mx plus b. So let's start with answer choice F. Okay, so x minus y is greater than -4. So we need to subtract x, so we get -y is greater than -x minus 4. Now, some of you guys are probably saying, hey, we can use that trick. We can use that trick where we just change all of the signs. That is true. But if you're going to use that trick, you need to remember that that is technically dividing by -1. And when we divide by a negative, I need to flip my inequality. So I'm still going to use the trick that I showed you guys earlier. It was -y, now it's going to be +y. It was negative x, now it's going to be positive x. It was negative 4, now it's going to be positive 4. But we are technically dividing by negative 1. And when you divide by a negative number, you need to flip your inequality. All right, so y is less than x plus 4. That has a y-intercept of 4. It has a slope of 1, which we can make into a fraction. All right, let's graph that. So y equals 4. My y-intercept equals 4. Sorry, my y-intercept is 4. And we have a slope of up 1 over 1. All right, that looks like it fits our line. Did we shade below? Yes, we shaded below. Is it a dashed line? Yes, it is a dashed line. Okay, that first equation looks good. All right, let's graph our other inequality. Sorry, I said equation there. Let's graph our other inequality and make sure it works. So we're going to subtract x. So y is less than or equal to negative x minus 1. All right, this is now in a format that we can graph. My slope is negative 1 over 1. My y-intercept is negative 1. Let's see if that fits. So a y-intercept of negative 1, and my slope is down 1 over 1. That works. Is it a solid line? Yes, it's a solid line because we have the equal to bar. Did we shade below? Yes, we shaded below. So answer choice F is correct. That looks good. So we got to 2 answers by using a little bit of prior knowledge, and then we used a little bit of math to get it to see which of those was correct. Easy enough. All right, number 13. Which inequality is graphed below? Oh, this is honestly, number 13 is just like number 12, but even easier. So first thing that I notice is this is a dashed line. And remember, dashed lines means there's no equal to bar. So automatically for my answer choices, I can get rid of A and C because both of those have the equal to bar. Also, we shaded below our line. Notice these are already in y equals mx plus b. So shading below means less than. That was easy. Answer choice D is if it was shaded above. Greater than means above. So wow, number 13 is super easy. Awesome. All righty. Number 14, last question. At an airport restaurant, 3 fries and 3 hamburgers cost $12. An order of 5 fries and 4 hamburgers cost $17. How much does 1 hamburger cost? Okay, so we're trying to figure out how much hamburgers cost because we don't know. And we're going to try to figure out how much fries cost because we don't know. So I'm going to call X hamburgers and I'm going to call Y fries. Okay, so 3 fries and 3 burgers cost us $12. So 3x plus 3 hamburgers and 3 fries. So 3 fries is $12. Now, guys, before I go any further, some of you guys are probably saying, wait, they said fries first in the problem and then hamburgers. Why did you do X for hamburgers and Y for fries? Guys, that doesn't matter as long as you are consistent, okay? So here's what I mean by that. In the next part, in the next sentence, it says we got 5 fries and 4 hamburgers. 5 fries, since Y is fries, plus 4 hamburgers, 4x, cost us $17. All right, so at this point, we could use substitution, we could use graphing, we could use the insolve that Mr. Arnett taught us. Personally, we're going to graph because we have the Desmos to graph for us. But remember, if I want to graph these, we have to get them into y equals mx plus b first. So 3x plus 3y equals 12. I need to get y by itself, okay? So we're going to subtract 3x from the left, which means we need to subtract 3x from the right. 3y equals negative 3x plus 12. Then This 3 is multiplying the y, so in order to undo it, we need to divide. So I'm going to divide both sides by 3. So y equals -3 over 3 is -1x, and 12 divided by 3 is 4. All right, there's our first equation. Let's go ahead and convert our second equation as well. 4x plus 5y equals 17. Subtract 4x, subtract 4x, which means 5y equals -4x plus 17. Then we need to divide everything by 5. And none of those fractions simplify, so that's as far as we can go. All right, so what we're going to do is we're going to graph these two equations. We're going to see where they intersect, and that's going to be our solution. All right, so let's go to our Desmos. Let me get rid of these old ones. So our first equation, when we converted it, was -1x plus 4. And then our second equation was -4 over 5. -4 over 5x plus 17 over 5. All right, where do they cross at? This is the point right here. So they cross at the point 3, 1. They cross at the point 3, 1. So let's go back and write that down on our paper. So what is the solution to this system? They cross at the point 3, 1. Now, guys, this is where we need to be really careful because they don't want me to put an ordered pair into our box here. What did they ask for? They asked for how much a hamburger is. If you look back, hamburger is our x values. So this point that we found, the point 3, 1, this is our solution, but they only care about the hamburger part of the solution. And hamburger was our x value, so that's why we're going to use 3 as our answer. So the hamburgers cost $3, and the fries cost $1, but all they're asking for is the hamburgers. So I'm going to come up here, I'm going to write in 3, and I'm going to circle, make sure I bubble in the correct bubble, and there you go. All right, that's your review. We did a lot of graphing today, so make sure you understand we got to get it into y equals mx plus b if we want to graph. When you're dealing with inequalities, if you ever divide by a negative, make sure you are flipping that inequality. All right, you guys are going to be able to submit this. At least for my class, you're going to be able to submit this. It should be a free grade. I will replace your lowest grade with it. And then also make sure before you take the final, you guys use this review on it. Okay, do not take the final without doing the review. All right, have a good day.